So for those of you who want a little bit more, or you're planning to do science in your future, or will come to AP Chem or AP Bio at some point, I just wanted to go into a little bit more detail on things that are no longer on the Regents exam, not that we're having one anyway, but does enhance your learning of chemistry. And that is this whole idea of spectator ions. So when you have KOH, which is a base, and HCl, which is an acid, dissolved in water, what they actually do is they float around as ions. So first let's do our overall equation. So this is going to be a neutralization equation because we have a base and an acid. So we're going to produce water. And then we're going to produce KCl, which is just KCl. So if I wrote this out like the phase of matter of everything happens in water. As neutralization reactions happen in water. So that says AQ if you can't see that. Water is pure water, so it's considered an L. It's not dissolved in water, it's just water. And then your ionic compound is also dissolved in water. So everything is happening in water, and you really can't see when a neutralization reaction happens other than if you put an indicator in there, which we'll talk about later. Okay, so if you're going to do an ionic equation, you're going to show the ions floating around. So because K is always soluble, if you remember that from table H, that's how I would write that. Everything's floating around in water. So those are the ions. And then if I go on this side, water always stays together. It's not an ion, it's just water, H2O, the molecule. And then I have K plus and Cl minus. And I think we may have very briefly talked about this. But what we're looking at first is the ions that are spectating, meaning they're just watching. And someday we'll be able to spectate sporting events again too, or play them for those of you who are on teams. But anyway, the spectator ions are the ones that are unchanged on both sides. So K is the spectator ion, and then the other one that's unchanged is chloride. Okay, so getting rid of our spectator ions, we actually end up with what's called a net ionic equation. So the net ionic equation for any neutralization reaction looks like that. So again, this is called the net ionic equation. So I would have you guys go ahead and pause the video and try this one on your own and see what you come up with, and then just check my answer. Okay, so what we're producing is water, and then we're going to produce K2SO4 on this one. And then if I balance it, I'm going to put a 2 here and a 2 here. So I'm going to balance first. You don't necessarily have to, but... All right, so then this one breaks up into 2 Ks, 2 OHs, 2 hydrogen ions, and this is how we write them, 1 sulfate ion, water, which again doesn't break up, 2 Ks, and SO4 minus 2. Okay, so looking at this, we can cross off our spectators, which is K is always a spectator, and then the other one would be the sulfate ion. So what we're left with, the net ionic equation, notice in neutralization, the net ionic equation is always going to be the same thing. And then in this case, we can just get rid of the 2's. And notice the net ionic equations are the same.